Alright, we're at part 3, comparing the side length, the sides and the heights. Okay, so small to large, so I got the small side to the large side, I got the small height to the large height. Now we want to go ahead and reduce these if we can. Okay, so 4 to 18, they told us they're similar, but we always got to double check. 4 to 18 is going to simplify. Actually, we could divide both of those by 2, we get 2/9. And then 6 to 27, we can actually simplify that as well to 2/9. And what basically that means is we know they're similar and we have my scale factor. So the first thing that we have is the scale factor. Okay, so it asked me to find the scale factor, which is going to be 2/9. Okay, next I want the surface area ratio, or SAR. That's going to be just squaring the 2 and the 9. So that's going to be 4 and 81. And then it wants me to find the volume ratio, the VR, virtual reality, if you will. And that's going to be 8 over, and this is going to be a quite large number. We're going to do 9 to the third power, which is 729. Okay, so there it is. Find that scale factor, and then go ahead and find, and then go ahead and find the squared version and the cubed version. Alright, finally, back page, number 16 says if the scale factor is 8 to 5, what's the surface area and ratio? This one's really a lot easier than even that last one. We have scale factor versus surface area ratio, or factor, versus the volume ratio. Okay, so remember we learned A to B, A squared to B squared, and A cubed to B cubed. So if it's telling me it's 8 to 5, I just need to square these. So I have my calculator right here. The first one I can do is 64 and 25. That's easy. The next one, the numbers are a little bit bigger, so I just use my calculator. 512, and then we get 5 to the third power, which is a little easier to do, which is 125. So these are my two answers for the volume and then the surface area. Okay, these last three are kind of challenging, so let's get to them. 17. Okay. 17 states we got the volume of A and the volume of B, and if they're similar, what's the ratio of the surface areas? Okay, so this is for sure going to be on your test. We get 28 over 1,792. Okay, so I'm going small to large again. If I can, I want to try and reduce this, and you actually can. They actually both 28 fits into them, so I get 1 to 64. Since I'm dealing with volume here, okay, this should be equal to my ratio of cubes. So if I want my standard ratio, I'm going to have to cube root these. And you're going to see why I'm doing this in a second. Okay, so I'm going to cube root these. So if I want to get what A to B is, it's going to be the cube root of these. So that's going to be 1 to 4. Now it asked me for my surface area ratio. That would be A squared to B squared. So that's when I take the 1 to 4 and I square it and I get 1 to 16. That is my surface area ratio, the SAR. Okay, so kind of tricky how we had to do that. We had our volumes, we put them in a ratio, I reduced them, then I had to go back to my original A over B, so then I could square it to get A squared over B squared, which is 1/16. Number 18, similar problem. We have the surface areas of 80 to 245. So we're dealing with the SARs is what we're looking for right now. So that's A squared and B squared. I need to start out with just A and B. Okay? And right now you're looking at these and you're like, there's no square root of 80 and 245. So let's try and reduce 80 and 245 first. Now, some of you have a calculator that will do this for you. Others of you are just going to have to kind of try, first divide by 5, then see what else you can divide into. But if I reduce this first, then I can get this, because this won't work. We'll have to get it to this point here instead. Okay, that's when we're going to take the square root. I don't know why I put 2 in the index. You don't even need to do that. Okay? From here, we can get A to B really easily. A to B is going to be 4 to 7. Now it says find the volume of A if we have the volume of one of them. So we can go 4 to 7 equals the smaller on top, I don't know, to the larger on the bottom. Well, the problem is this is in A to B. I need to put it in terms of volume. So I'm going to go ahead and cube it. So let's go ahead and cube that. And we're going to do this in my calculator. I get 4 to the third power, which is 64. So erase U and write 64. And 7 to the third power is going to be 343. Now I have the right ratio, not 4 to 7, but 64 to 344. And now we can just cross multiply. So I'm going to get 64 times 1029. So I get quite a large number over here. And then we divide that number by 343. And I get 192 millimeters cubed because I'm dealing with volume. I can't believe it, but we finally made it to our last problem. This is about 40 minutes of me doing these problems. Whew. I can only imagine it took you quite as long as well. Okay, so here we go. We got two cones, cone A and cone B. Cone A has a radius of 12. Cone B has a radius of 20. So my radius ratio is going to be 12 to 20. If the surface area is 275, what's the surface area of the other one? So it'd be rad if I could just go ahead and do this, you know, because 725 is the smaller one over the larger, but this wouldn't be true. First, I would have to go ahead and reduce this fraction. So let's go ahead and reduce this fraction. 12 over 20. What goes into both? I would say 4 goes into both. We can reduce this to 3 over 5. And this, again, we're dealing with surface area on this side, so it should be squared. So I can't actually leave it as 3 and 5. I have to square it. When I square this, this is going to become 3 squared, or 9. And this is going to become 5 squared, which is going to become 25. Now we can cross multiply and solve. So we get 725 times 25, which is going to be a pretty large number, equals 9x. Divide by 9. And we're going to get a decimal of sorts. We get 2013.8. And again, we're talking about surface area, so this is in square inches. Okay? Alright guys, that's the end of the video. I hope you enjoyed it. Hasta luego.